Good morning, everyone. These are the notes for 7.1 and 7.2. We're going to start with 7.1, solving linear systems by graphing. Now, you've actually been set up to do this from yesterday's activity or from Tuesday's activity. So one of the things that you're going to see on your homework is they're going to ask you this question. And the question is an ordered pair, do you remember what an ordered pair is? An ordered pair is just a point, right? They're asking, is an ordered pair a solution, and you've met this word solution, to the linear system? And they're going to give you some type of linear system, and we also have to define what is a linear system. So the question is an ordered pair a solution to the linear system? What they're really asking, so in case this sounds really confusing, they're asking, is the given point, this is really what that question's asking, is the given point on the two, sometimes it could be more, on the two lines that are presented. A system, a linear system, are more than one line graphed on the same plane. So that's part, it's asking, is the given point that they ask you, that they're giving on the two lines? Or another way of looking at it is, does the point work in both equations? So if they didn't give you a picture, if they gave you equations, they're asking, ultimately, they're asking, does the point work in both of the equations? Okay? I think you can figure out how to do that pretty easily. The next thing that I think is the hardest is actually to solve the system. Okay, so if they say solve the system, what they're really asking you to do is, I'm going to write this in parentheses, is find the point where the two lines intersect. You could have more than two lines, but in this case you're working with just two. Find the point where the two lines intersect. Okay, so that's our goal. So the first, in 7.1, they ask you to solve by graphing. Okay, so here's your first example. Let me shove this up a little. Here's your first example. Example number 1. We have negative x plus y equals 5, and 2x plus y equals 8. Now, we're asked to graph this, so I'm going to go ahead and make my coordinate plane. I'm going to grab my ruler so I have it a little bit neater. You're going to want to use graph paper for this, so ask the substitute for graph paper. First step, put into slope-intercept form, right? Isn't that the easiest to graph it? You could make a t-table, but I'd like to put this into slope-intercept form. So to put this one into slope-intercept form, add x to both sides. So we end up with y equals a positive x plus 5. This one, I'm going to subtract 2x from both sides. So I'd have y equals negative 2x plus 8. And then I need to go ahead and graph this. Now, it looks like I didn't make enough room to count 8. So I'm going to make these a little smaller. 1, 2, 3, 4, 5, 6, 7, 8. Here's 8. I am counting by ones, but unfortunately I made this a little small. Okay, here's 2, 4. So I'm going to first start by plotting this equation, x plus 5, y equals x plus 5, y-intercept of 5, and I have a positive 1 slope. So I go up 1 over 1. Up 1 over 1, up 1 over 1, and so on. I'm going to use a ruler. It is really important to use a ruler if you really want to find, get accurate results on this. So there's that line. I'm going to continue my graph throughout my coordinate plane. Then I'm going to graph this one. So I have a y-intercept of positive 8, a negative 2 slope. So down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Connect these dots. And you would have already immediately seen where they actually cross, where these two lines cross. They cross at this point here. That point is at 1, right, over 1, up 6. Now, how would you check that? How would you verify that 1, 6 is the solution to my system? I could check by plugging in, right, plugging into both of these. Is 1 plus 5 equal to 6? Is negative 2 times 1 plus 8 equal to 6? Yes. So I could check by plugging back in. Okay? Here's another example. I'll give you a second example just in case you need to see that again. So second example, let's get a little tougher. X minus y equals 5, and 3x plus y equals 3. We need to put both of these into slope-intercept form, so I'm going to subtract x from both sides. And then I need to make sure that my y is positive, so I'm going to divide everything by -1. And I get positive x minus 5. This looks very similar to the previous problem. And then this one I'm going to subtract 3x from both sides, and I get y equals -3x plus 3. So I'm going to go ahead and graph this one as well. I hope I have enough room on this graph paper. Let's see. Alright. So I'm going to count hopefully by 1. So I have a -5 y-intercept. So here's -1, -2, -3, -4, -5. So here's my y-intercept. I have a positive 1 slope, so that means up 1 to the right 1. Up 1 to the right 1. I should be counting by 1s here. Up 1 to the right 1. I'm going to go ahead and connect my dots. So there's that line. Sometimes it's helpful to label your lines, especially if things get kind of ugly. And then I'm going to go ahead and graph this line. I have a positive 3 y-intercept, so up here, and I have a -3 over 1 slope, so down 3 to the right 1. Always give it to your numerator. Give that negative to the numerator. Down 3 over 1, down 3 over 1. I'm then going to connect the dots and see where they meet. I actually saw already that they meet nicely here. You see how graph paper and rulers really help? And that point is 2, -3, right? 1, 2, 3, 2, -3. That is the solution to my system. I'm looking for the point where they meet. Now what I'd like you to do is do the front side, try it yourself, do the front side of this activity with the substitute. And I'll give you guys, hopefully the substitute will give you about 10-15 minutes to go over this.